I'm going to prove this theorem. You have a basis for a linear space, and B is not a proper subset of any linearly independent set of vectors of V. Well, I'm going to let B be equal to, say, B1, Bn. We know it's a basis, so it's linearly independent. I'm going to consider, how about B prime equal to, how about B, sorry, that's going to be equal to, B prime is equal to B, all the elements would be together thrown with some element, I don't know, C. We will show B prime is not linearly independent. And I'm going to start with, since B is a basis, B spans V. So there are scalars C1 up to C, about A1 up to AN, I already used C's, such that A1 B1 plus A2 B2 plus plus AN BN. Well, since it spans, I can put any element of V there that I want. Well, I'll tell you what element of V that I want. I want it to be equal to C. B is a basis, so it spans, so I can find these scalars such that it equals C. Then A1, should be A1 B1 plus Bn plus minus 1 times C is equal to, well, if I group these together, I get C plus minus 1 times C. That equals 0. But one coefficient, -1, non-zero, so B prime is not linearly independent. So what did I done? I've shown that take your basis, throw any other elements you want right here. I'm going to show that that is not a linearly independent set. How? Well, I know that this is a basis, so I can make C with these scalars. So I make C with those scalars. I add -1 to it, and then I end up with a 0. But that's not equal to 0. So not all the coefficients are 0, which means that this is not a linearly independent set. Which means that if you take a basis and throw anything else in there, you are definitely going to get a linearly dependent set. It will not be linearly independent. End of proof.